Hi, good evening, and welcome to the daily live session on various topics for execution excellence. My name is Dinakar. I'm the founder of Samuthana and the inventor of Do How, a methodology for driving teams to achieve challenging goals and amazing outcomes, and while doing so, get them to develop a different mindset and culture, and at the same time, acquire leadership and management skills and progress on the journey towards smart manufacturing. So on the right side here, you see the leadership, which is all about doing the right thing to choose the right target, and below that is my what should I say explanation of mindset and culture. You can watch that; it's a different video. And on the left side, you got management on the top, which is all about the system and doing the right thing. And below that are the PDCA cycles, which I'm going to be explaining now for moving ahead on the journey towards smart manufacturing. So that's what we do. In case you want to understand a little more about what we do, please do visit our website, dinakarmurthy.com it is. Otherwise, you can also write an email to me. Dinakar@samuthana.com is my email address. So with that very brief introduction, let us directly jump into the topic, which is about smart manufacturing. Yesterday I had done this, spoken about this introduction, where I'll start about this introduction every day because smart manufacturing is all about uh, trying to use hardware and software technology for assisting to fully managing repetitive tasks within an environment or ambience in manufacturing industry. So you got an ambience. In that ambience there could be a lot of repetitive tasks. It could be either to do with machine or to do with people, and to be able to use technology to either make it assisted in doing that job or make it fully automatic so that it manages the entire thing fully. So in doing that, there is basically the fundamental control cycle that I need to explain, which is to first of all control, where there is some kind of an algorithm which is used to define what needs to be done, and that is the control part of it, the controller, and which could have the computer, which could have a set of programs, and then which could have various databases and memory, and all that is part of the control phase. And then once the control is done, it knowing what to do, then after that it has to be actuated, and that generally would be again in a embedded program with some kind of an actuator where the program is embedded. It's an embedded software where it is going to communicate with that particular device to actuate it either through a stepper motor or a linear motor or hydraulic or pneumatic cylinder or whatever it is. So that's the actuation part of it. Then comes the sensing part of it, which again would possibly have embedded software in that, wherein you're trying to sense either the temperature, pressure, dimension, or whatever. And then comes the activity of correcting the fundamental algorithm and the prediction which was done for actuating. So that's the cycle. And this needs to be continuously happening. If you see on the left side here, I have shown that the actuate, maybe I can put on the laser pointer. I think let me see, put on the laser pointer if that is possible. Yeah, there it is. Yeah, that's a good one. So here the actuate part of it is something which is going to happen in the environment, sensing part of it which also will happen in the environment, and whereas control and correct, this is something which is the core of the intelligence. So if you look at the my pictorial, the control and if correct, they are something to do with the leadership, and sensing and actuating is to do with management, because execution is management, thinking and deciding what to do is leadership. So again, to get an idea and connect between leadership and management. And what is important is that the sensing can happen anywhere in the environment, needs to happen, and the actuation also could happen anywhere in the environment. So with this very brief introduction to the control concept, and then let us get into the topic of the various cycles. So I say that in the case of the next slide. Yeah. So here there are multiple cycles. One is the product cycle, process cycle, people cycle, performance, productivity, programming, and progression cycle. In the level of, as the level of maturity increases, one would go to the higher level of the cycle. And these are the cycles which I had shown in my pictorial. If you look at my pictorial on the right side here, let me just find it out. Yeah, there it is. On the this basically are the cycles which I'm explaining now. I'm starting with the product cycle and then go up to the last cycle, which is the progression cycle. That would be the way I'm going to go ahead in the next 7 weeks. So with that very brief introduction, let me now get into the next topic. I don't know why it is not working that seamlessly. Yeah, now it is easier. Yeah. So now yesterday I spoke about the product cycle, which comprises of idea workshop, which I have done quite a few in Germany especially, for finding out new generations for existing products. Blue Ocean workshop, done quite a few with my clients in as a consultant and a coach. Scenario and mega trends, this I used to do when I was working on trying to understand whether a particular technology in Bosch which was developed would make sense for us to invest in it and get it further developed and then launch it and use it as a product later for manufacturing, because we had a lot of research activity going on in our corporate research department. Hackathons and innovation workshops are something which is new, which is what can be done in colleges. So these are the 4 areas where one could work on to really get an idea as far as what the product is, what product can be manufactured or what product can be conceived as far as the business is concerned. So once the product is understood, today we'll talk in detail about the minimum viable product. I think you must have heard of this word. MVP is what it is called as. That means it's a product which can be shown to the customer for tasting, which can be used for some kind of initial trials, functional trials, or it could be for field trials or whatever kind of trials. So this product has to be manufactured first. That means you have an idea. From the idea it has to come to the product. Now to do this, there are 4 activities which I have listed out which are extremely important. Let me start from the bottom. The first and the foremost is the vendor development. See, the vendor development for minimum viable product or prototype manufacturing is something totally different than vendor development for mass manufacturing. Because when you're talking about mass production, you would possibly look at systems, you would look at what kind of certifications would they have, is it ISO certified, is it AS 9000 certified. So that would be the main criteria, apart from looking at what kind of customers they are serving and what kind of competencies they have got and what is their vendor base, how is their ecosystem, all that one would assess. And what is the structure that they have got, hierarchy, how many people, is it only one man dependent or is it a organization which is run professionally. All these factors are considered when a vendor is established for regular manufacturing, when you are trying to source it for regular production. Whereas for prototype manufacturing, the conditions and the criteria are totally different. It would be mainly to check if the vendor with whom you are cooperating, with whom you are collaborating, has a innovation mindset. That is the key, most important thing. Whether he's acceptable to going in for that innovation activity. And second is, what is the person's competence? Is he prepared to do one piece? I'm only looking at one piece now. I don't want mass production. So there, the availability of systems, availability of lot of structure in the organizations possibly is not the ideal way at all. Because just listen to me, in the case of prototype manufacturing, it's best to go for such vendors who are very smart and very, very quick. They're quick, smart, and they may not have any systems, they may not have any, and it could possibly, most of the cases, be one-man show. Because why do I say one-man show? One-man show is where there is one person who's really good at doing something and he's the one who's doing it. It's something like a craftsmanship, because that kind of an industries and vendors is what it is required. So that's the first activity of vendor establishment. Once that is done, now we have got the vendors established, then we go to the CAD CAM. That is again another interesting thing. See, today, in today's technology, for vendor establishment, it is not really a computer-based activity. It is nothing smart there. The only smartness comes in understanding what kind of factors do you use for enlisting the vendors. CAD CAM with DNC, again, their smartness is there, tremendous amount of smartness. There you are trying to convert the drawing. See, today there is no product which is only sketched on paper. Everything would be done on CAD, whatever be the software you are using. And from there, directly convert it into a program and transfer it on DNC to your CNC machine would be the best way. Because normally any company which is in some kind of an innovation would have a simple machine shop. Maybe they would have a VMC and maybe a turn mill center, something small, where you are able to manufacture to some extent some components on your own. Because many of these things could be real secrets. One of our clients manufactures a product where they've got a kind of a valve which is working as both input and output valve. It's called as the IO valve. So that's something which is very complicated design. Now, the way of getting it to work as both input and output valve is the way the internal connections have been done, and that's done on a CNC machine when they made the samples. And of course, it can also be done in additive manufacturing. I'll come to that later. Now, such components could be a little critical because you're in the development phase. This product idea could be copied by somebody. So typically, one would have at least a VMC and a turn mill center. So in these two machines, you could have a DNC, which is a link between your computer and the machine for transferring the programs directly onto the machine. So there's no question of any programming happening there. This is something which is necessary for gaining the speed. That is the second aspect which can be done, that their smartness is possible. Many companies do that today. There are a lot of companies who have CAD/CAM with CNC, with DNC integrated, and so that's quite a state of the art today in industry. Then comes the additive manufacturing. When I say additive manufacturing, this is about 3D printing. Of course, you have heard of 3D printing. No rocket science now. Everybody talk about 3D printing, and here the core is to understand the load on the component before you look at 3D printing. That's the key, which I have learned. Again, their engineering is required because depending on the load and depending on the fatigue load, either the part can be 3D printed or has to be manufactured using a cold forged or a drawn raw material. Drawn means hot drawn or cold drawn raw material. Typically, how is the metal manufactured? You've got the particular steel which is manufactured, goes into the furnace, and from there you pour it into ingots. Ingots are massive blocks, and from the ingot it is either rolled, cold rolled or hot rolled into wires or sheets or whatever be the way that we buy the material in the market. It could be bars, it could be sheets, it could be anything. So that process of cold rolling and hot rolling creates a flow of the micro particle, the structure in that particular steel, which would be something like this. You got lot of structures overlapping, and this is something which is very, very important. When you look at it, the molecules in the steel are basically extruded or basically enlarged, and that kind of a formation is something which makes the steel much stronger when it comes to fatigue strength. Whereas in the case of additive manufacturing, you are basically welding two items together, two molecules together. Therefore, there is no concept of the structure and the flow of the structure. There is no structure. The microstructure would not show you that it is basically overlapping and like this, which is what happens when you are doing rolling or cold rolling or hot rolling or extrusion, forging, these processes. In fact, if you want to know what is the true strength of that, if any of you are interested and have that as a hobby, you can check out the way Ninja sword is manufactured. When I was in Germany, I had a barber who would charge close to about 50 or 30 or $50 for one haircut, and I used to go there once in a while, not regularly. And this guy had Ninja scissors. So he said the scissors itself cost him somewhere close to about $15,000 or something like that. 15,000 euros those days. Because dollar and euro more or less were the same when I was there, and only then it became quite different. So this guy had these scissors, and I believe to manufacture those scissors, they take almost 6 months, because the way it is done is you take the metal, heat it up, and then basically flatten it out, and after that fold it, and again keep on beating it, and so your scissor is basically a piece of metal with multiple layers of flattened metal, and then it is sharpened. So when you are trying to cut the hair or cut anything with that kind of a scissor or with the ninja knife, sword, you are basically having multiple sharp edges at the point where the cut has to happen. Therefore, it's extremely sharp and extremely effective, and that can be only and it is very, very sturdy, very stable, because it doesn't really break, because of this process of continuously beating the metal and then making it flat, so that you create this kind of a structure in the metal. Whereas in the case of additive manufacturing, it's like this. So the understanding of the fatigue requirement of the particular component is extremely important for choosing whether you can do additive manufacturing or not. And when you do additive manufacturing, here we are talking about metal additive manufacturing. Therefore, it's a little challenging than the conventional plastic or ABS, additive manufacturing, 3D machines which are available. So therefore, I use the word additive manufacturing and not really 3D printing here. So that's something which is where one could automate, provided the way the what should I say, fatigue load of the component is understood. That is the next which is possible. And here, apart from the additive manufacturing of 3D printing, there are also possibilities where you could do galvanic printing. That is not 3D printing, where you basically deposit material one on top of the other using the electrolytic process. That's again additive manufacturing, but it's a different technology. So there again, you need to have a lot of in-process control, which means that there is a lot of programming, a lot of smartness in that entire machine, similar to what is there in 3D printing. So that's the next smartness which is possible in the minimum viable product. And finally, when it comes to prototype manufacturing, there again, there is a tremendous amount of smartness which is naturally integrated, because when you are doing the prototype, minimum viable product, it's not just about making the product, it's also about understanding the difficulties in the process, understanding the complexities in what we do. Therefore, a lot of measurements are done normally. And there again, to really collate this information, later to be able to analyze and build correlations between the end effect and the end outcome and the individual dimensions is extremely important. And there again, a lot of smartness can be used for big data analytics. It's not really big data, it is data analytics and data science, because you're trying to understand whether the diameter of the shaft has any influence on the opening pressure of a particular valve, or does the diameter of the shaft or the clearance between the shaft and the coil, does it have any effect on the magnetic force in a solenoid valve? Things of that kind need to be understood. Or does the material composition, how much amount of carbon is there in the steel, does it have any impact on the hardness of the material? Such things have to be understood. Therefore, it's important to use smartness there for data collection and analysis, so that later when you get into the series production, there is also already a base available from which we can build upon, to make sure that from the day one there is a kind of an interrelationship between the actuation and the sensing. That's the topic which I spoke earlier. So that's all about a product, minimum viable product, which where you could use smart manufacturing concepts in these 4 areas: prototype manufacturing, CAD/CAM with DNC, additive manufacturing, and vendor establishment, where it's all about using the smart know-how and not really computers in this area. That's from my experience, which I shared with you. Yesterday I spoke about the product cycle. Today I spoke about the product cycle and product idea. Today I spoke about the minimum viable product. Tomorrow I'll be talking about how would you understand the potential and the profitability of this particular product which we manufactured, and what kind of smart manufacturing ideas can come in there, and which I've been associated with. Not that a lot of things are possible, I'm only talking about where I have been associated with. That I'll explain tomorrow. And then after that, we are going to talk about what decision has to be taken to go to the next level. That's again which will next cycle, which is to really look at how do you go, whether you go to the next cycle or not, and then what is the acting phase will be on Friday, and finally I talk about the process cycle on the next week. That is the idea. So let's now stick on to whatever I've been doing here. I'll talk about the product cycle and potential and profitability analysis tomorrow when we meet at 8:30. So thanks a lot for watching. Have a nice evening, and wish you all the very best, and take care. Good night.